afternoon. I'm Ray Wang. I'm a product manager on the Google Cloud team.
And I'm JJ. I'm an engineer on the cloud platform.
So in the last couple of sessions, you have heard about how to design and build an application. The app is built. It's ready to go. And now what? That's the topic we're going to cover in the next hour, how to deploy and operate your application on Google Cloud. Okay. We're going to look at how to deploy changes, run operations, monitor application, and leverage Google Cloud's SDK and CLI tools. Clicker, great. So this is when technology doesn't always work. So first, let's talk about deployment. Deployment is when your application goes from a bunch of code, configs, binaries, to the product that your customers can actually use. And you don't just do it once. It happens every time you're shipping a change. Deployment is the lifeblood for your application. We're going to rely to clicking. A Google engineer, Brad Slatkin, tracked his team's happiness and motivation levels while building the application on App Engine. His tracking data showed that deployment is highly correlated to his team's morale. The three highest points during a development lifecycle happens when you first commit a code, and then when staging is deployed, the app is almost looking real, and then finally, when the release hits production and the product is being launched. So you would say deployment is a great thing, right? It makes developers happy, and what makes developers happy tends to be pretty awesome. But for those of us who do it day in and day out, we also know it can be hard. Here are some common problems that you might have faced. First, you want to make sure your deployment is repeatable and predictable. You don't want one-off tweaks or unique snowflakes, because chances are, at some point, you're going to forget to do them, especially under stress. And that can cause failures or even downtime. And downtime, you really don't want to have that. But let's face it, every time you're changing your system, there's always the chance of shipping the bug that can bring down your site. So you want to make sure bugs are found early and an impact is contained to the smallest possible scope. Troubleshooting and recovering from these issues also need to be easier. Now, deployment isn't just about moving a bunch of binaries to some VMs, right? We all know there are a lot of other activities that tend to accompany deployment. For example, your release workflow can include build and test. And during deployment, you might need to do things like stack switching, data migration, network configuration. And all of them need to come back to being repeatable and without causing downtime. So now let's look at how to solve these hard problems on Google Cloud to achieve a great deployment experience. JJ.
Cool. So I'm just going to talk a little bit about some of the things that you probably have already seen a little bit of today in the previous demo, for example. So I have a couple examples here with App Engine. For those of you who aren't familiar with this, it was mentioned in the last presentation. We have this whole components update app thing that's sort of a precursor to running the next command, which is gcloud preview app. Now, you'll notice one of the commands is bolded, which hopefully is pretty obvious. And you saw that in action a bunch of times. I want to make this kind of draw attention to the fact that it's one command to do a simple take my code and push it to a live production server. When we were deploying in the old days when we were a startup, it wasn't exactly the same as just running one command. You usually have a lot of scripts. Everything's very, very complicated. And having this here means that you can make it repeatable and automatable, which means you can hook it into a build system. You can put it into a script. You can do all sorts of things with it. At the bottom here, it doesn't just stop at this magical gcloud command. There's more to this. So you see these two, again, they're precursors, gcloud auth login. I think you saw that before. We mentioned that it does sort of this OAuth 2 song and dance to make sure you are who you say you are. The next step is this init and then a project name, which configures your local environment and gets things set up. And I'll talk a little bit more about that later. And the last thing is git push origin master. Now, at first look, you think, OK, well, I'm pushing to source control. What's actually happening under the hood here is we set up a Git repository on Google servers. And whenever you push to it, it treats it like production, which means that your code is actually being pushed the same way it would be with this deploy command. And so we're really trying to embrace the tools that everybody already knows. I think most people here are probably familiar with Git in some level. And what this does is it lets you use tools that you already know to do the deployments that you might not be as familiar with. So the thing to keep note of here is just because you can deploy your code doesn't mean you should always just push it immediately to production. I think there's probably people who do that, but in general, as you grow, you want more of an organized way of taking your code, pushing it to the live production machines, and having it be tested and know that your builds worked, for example. In Francesco's example before, we noticed he had a build process that failed a couple of times because of typos. If you had just pushed your code and then hoped everything worked, that wouldn't be so great. You would have downtime. So what we have here is release pipelines, which is in preview right now, or beta.
Beta.
Yeah, so what this does is it actually listens on that same hook that you have for your Git repository, and it's going to look through and monitor for these things, and then it has a 3-stage process. You can see there's build, test, and deploy. And what's happening at each step is it's using Jenkins under the hood, and I'm sure plenty of people are familiar with Jenkins. But under the hood, it's running the full build. So for Java or Go, right, Python, you don't necessarily have a build step. But for Java or Go, it's going to do the compilation, make sure you don't have any syntax errors or other compilation time errors. Then it's going to run all your unit tests, and hopefully you have some unit tests. And then finally, it's going to do the actual deployment, which is what you'd get if you ran gcloud preview app deploy. And you can see this last example here. You had a failure on deployment, but you're able to go back and actually say, try it again. Something must have gone wrong. Everything seemed to work. And what this lets you do is make your deployments automatable and repeatable and easy to manage, because as you know, we just learned that deployment is one of those most exciting parts of writing software, but it really can be a huge bummer if you try to deploy and everything falls apart. It's one of those things that we just never want to see happen. So this helps you make sure you don't do that by integrating Jenkins and all the other tools that you probably know, Maven, Ant, etc. So that's App Engine, the platform as a service. Wes talked about this as a continuum. You saw kind of using a hybrid of these things in the last example with Redis on Compute Engine, and then App Engine for your sort of webhook serving with Go. But what about Compute Engine? So you saw examples of clicking that SSH button to pull open a window. That's a great tool. But how exactly can you repeat that? Clicking a button is not one of those automatable tasks. gcloud compute SSH is the simple command that drops you into the terminal. Again, this is the SSH in the browser window, but you could pull this up on your local Linux environment. At that point, you can actually do things like apt-get install. If you put a -y in here, you don't have to actually hit the yes key when you're installing, right? But this lets you do more repeatable things. You can put this into scripts. You can pass a command as well. You can say what container you want to use, a different user, which instance you're trying to talk to, all these things. And if you take out the gcloud compute, it kind of feels a little bit like you're just running regular SSH. And so everything you could do with SSH and script, you can do with this. But that's not always the case. We all saw that Francesco had this new instance shell command, and it was a big blob of stuff that hopefully you didn't all try to write down. But say you want to turn on something specific when you are starting a new machine. So in this case, Francesco was turning on, I think it was 20 or so Redis instances. He had to write a special script to do that, and then he used a snapshot image. But say you don't have a snapshot yet, or you're not sure if you want a snapshot, there's other options. You can use this whole startup script idea. Now, the point here is you're able to turn on a new instance. We're calling it simple Redis right here. And then you can say, I wrote a shell script that I want you to run whenever this machine turns on. And so in that case, this one happens to be installing Redis, which is exactly what we want. And it can go through the whole song and dance to turn things on, which means everything suddenly becomes much more automatable, much more repeatable. And you can write scripts that rely on this type of thing. So back to App Engine. We don't always want to deploy everything immediately. Imagine you have a huge change that you're not sure how it's going to work in production. So App Engine comes with this concept of versions, and it's been around for a really long time, but it's not always sort of brought to the surface. So I just want to give a quick demo and explain what this is. So versions are the ability to have different copies of your code that might be slightly different. Let's say in this case, the Abalana app has a new way of showing pictures, and you fix a problem where old pictures are showing up. You're not sure if it works, and so what you can do is deploy a new version, and then these two pieces of code can run simultaneously next to each other, depending on the domain that you put in. So it's version.yourapp.appspot.com. Now, what this means is new versions that you have that might be experimental or something new that you're trying to explore and see if it works with your users, you can deploy that concurrently and then try it on this new URL. Or you can use this concept of traffic splitting, where you send part of the traffic to one version of the app and part to the other version. Anybody who's familiar with A/B testing is probably understand what I'm talking about. But anyone who is familiar with A/B testing also knows that the infrastructure and tooling around A/B testing is not always as great as you want. It's kind of frustrating, and it takes a lot of time and investment. And so what we're trying to do here is make it so that you're able to use traffic splitting without spending 6 engineering months to build the tooling to do it. So this is the screen. I'm going to show you a demo in a second. Oop, go back real quick. Yeah, so this is the screen when you're turning this on, and I'll show you the demo in a second. But what we have here is there's two ways of splitting traffic. One is based on your IP address. It's the idea that depending the IP that you come from, it splits based on that. The other is a cookie, and that's more random. If you have a big office environment that all share the same IP coming out, you want to use a cookie. So for my demo, I'll use a cookie since we're all in the same room. And then you see here, you can choose the amount of traffic you want to send to a version. And then it's not as prominent here, but it says route the remaining 90% of traffic to the default version. There's always this concept of a default version. So let's do a quick demo. There's a QR code here. If you guys have a phone, I'm actually going to try this too. You can scan this or go to trafficsplit.appspot.com. So it brings up that URL. And then if you load it up, it should be one of two colors. For now, you should all see it be blue. And then I'm going to pull up and show you how we can actually do some live traffic splitting. So here is the two versions. You all see blue as the default, so if you loaded it up, you'll see blue on your screen. I'm going to let you guess what red does. It's pretty straightforward. But what we'll do here is we're going to do another split. And I'm going to change this to say, let's do 50% of the traffic should go to version red, and we're going to route the remaining 50% of traffic to blue. We're going to turn this on. And then it gives us a second, and let's see, it says it's on now. So if you want to refresh the page, some of you should start getting red, and some should start getting blue. And for example, let's see here, I still have blue. Does anybody have, oh, there's red, red. Oh, wow, look at that, about 50% of the room, weird. So what we have here is the tooling is all built in, right? This means that you don't have to go and build your own infrastructure to do this A/B testing. Now, this example of red and blue, like you would never use this exact example. It's just for a demonstration, right? But imagine that you built a new machine learning algorithm in Avalana where you change the timeline depending on who's doing what. You decide that you're going to show pictures from friends of friends and see if more people start liking them or start doing more follow requests or whatever it is. Well, you can actually do this on an API level where you keep the app exactly the same, the Android app. And the API, when in that get images thing that Francesc wrote, could return different stuff. And then you'd have two different versions running concurrently, and you'd shift maybe 5 or 10% of traffic to that new version, which sends different images down. What that means is you can actually test out how things work and understand if there's any huge improvements or if you're really just wasting your time and should roll back. The other thing is performance improvements. Say that blue was really, really fast and red was much slower. I'd find out quickly because I'm shifting it to only a subset of users instead of to everybody. And so you're able to do this without experiencing lots of downtime. So, oops, we got to go back here and present. And now Ray is back.
Okay, now let me tell you a few customer stories about how some GCP customers have made use of the tools and best practices that JJ just told us about. Streak.com is a CRM site built on App Engine with a peak traffic of 1,500 QPS. Streak has a very agile deployment process, deploying 5 to 10 times a day. They run the integration tests on test farm on GC before gradually rolling out the new deployments. Now, the way they roll out the deployments is using the same traffic split tool that you just saw JJ demo. First, they stand up a new version of the front end, then they send 1% of the traffic there. Over time, they increase it to 3%, 5%, 10%, and eventually to 100%. That's when the deployment completes. When I talked to Streak's engineering team, they told me that they have greatly benefited from practice of continuous integration and deployment. When you release frequently, every deployment is small, which reduces your risk and makes troubleshooting a lot easier. In the rare cases when Streak ran into a bug during deployment, because the change is small, the impact is usually fairly mild. And because the change is small, the engineers can quickly figure out the culprit code, make a fix, and roll forward. Let's look at another customer. We all know about this one, Snapchat. Every day, Snapchat enables millions of sharings of photos, videos, and stories. You might remember some of their recent story releases, such as the Electric Daisy Carnival or Austin City Limits Music Festival. Every time a new story gets released, it is delivered to the inbox of a huge number of users, resulting in massive traffic spikes. Snapchat rolls out these changes by gradually shifting traffic to the new version over a period of a few hours. Snapchat's team also regularly uses traffic split to tune performance improvements to make the app faster and smoother for users. We mentioned that there are often other activities that go along with the deployments. Let's look at them in more details. Let's take the example of the app Abalana. If you were to roll out a major upgrade to Abalana, what you might do is to stand up the new front end first, and then update your data structure, upgrade the binaries on your VMs, recycle them, reboot them, and then start switching traffic to the brand new front end. You want to make sure these activities can be sequenced in a way that's repeatable and predictable. And to solve these orchestration problems, the open source configuration management stacks such as Puppet, Chef, Ansible, and Celt are commonly used. Google Cloud has contributed to these communities plugins, templates, documentations, and demos to make the integrations a great experience. Let's take Puppet as an example. What you see here is the GC compute module in Puppet. It contains the resource type definitions that describe the configurations of compute engine resources. And this allows compute engine resources to be modeled as native Puppet types. So you can see here both the raw resources, things you're familiar with, such as instances and disks, as well as the management objects like network configurations or target pool configurations. Let's look at how this is used to deploy a real-world app. So one of Puppet Labs' own apps, Puppet Forge, is in fact deployed on Compute Engine using the Puppet integration that you just heard about. Now, as some of you might know, Puppet Forge is the platform where sysadmins and developers can share and collaborate on infrastructure as code in Puppet's domain-specific language. 900 organizations and individuals have contributed over 2,500 modules so far. And every month, it's visited by over 35,000 developers. So the diagram you see here is the dependency graph that allows Puppet to figure out how to sequence the deployment activities for the Forge application. If the end state is to have these VMs at the bottom deployed, then this graph tells Puppet first you have to go and configure the things about them, including the firewall configurations, health check, and forwarding rules. This allows Puppet to be able to automate and then repeat a sequence of deployment activities. Using the automated deployment process, the Forge team is able to stand up a brand new version of the Forge instance in less than an hour on Compute Engine. And with that, they get to deploy usually several times a week or sometimes even multiple times a day. So let's say now your app has been successfully deployed. It's up and running with the latest and greatest of the features that you have created. Next, you want to make sure that your app is monitored and stays healthy, and any anomalies are brought to your attention right away. So let's look at the monitoring experience on Google Cloud.
Cool. So just like Ray said, monitoring is incredibly important. I think we kind of underestimate it generally. The app is deployed. If it doesn't work, you need to know about it. It's one of those things that we, and most engineers I know, me included, tend to forget. We think all about the coding part and less about the operations and production part. So there's a few things that are pretty complicated, and I can totally attest that these were complicated in the past for me. So first of all, setup. What I mean by this is just the ability to see how many requests per second your web server is handling. Right off the bat, that's not a simple thing to do. Right? Understanding this, there's a lot of services out there that you can use. Graphite, for example, Keen.io. There's a bunch of interesting metric tracking services. But just keeping track of them is work. It's something you have to actually do. You don't usually get it just for free. After that, let's say that you have all this data. It's usually not from one place. Typically, there's maybe 5, 6, dozens. Who knows? How many places we all have data stored? There's probably a bunch. And we need to get this all in one place so that we can actually do real work with it. And that's not always an easy task either. Hopefully, it's a little easier than the original setup. But lastly, this idea of insight. Having data is very different than having knowledge. Raw data is useful only if you're able to get something out of it. And so having all the data in the world and no ability to query it, no idea what it means, it becomes absolutely useless, and then it just shows up as a bill on your BigQuery bill or your cloud storage bill, and that's never fun. So these are the complicated parts. How do we actually fix this? There's a few ways, and Ray and I are going to talk about a couple of these, and you've seen these a little bit in the previous demos. So first of all, the dashboard. I think we kind of scrolled right past this in all the previous demos. It's been around forever, but it's one of those things where it gives you something for nothing effectively. If you're running an App Engine app, you can see all the requests per second, for example, and lots of other stats. And we're actually going to pull up the stats for that Abalana app. I hope it's the live one, but we'll see. So this is, I'm just going to refresh. You can see this is slightly different app ID. I'm not sure if this is the production one or not. We'll see in a second. But what we're going to see here is the dashboard that I just showed before, but it's actually going to be real. So here is a summary. This is talking about requests per second. Not a whole lot, but this is just the last hour. We can zoom in or zoom out here and see in the last day. And as you can guess, these are spikes from about 1 p.m. when we started sharing the link for the thing and everybody installed it. You can also see things like latency. How many people off the bat immediately get for free how latent your application is? It's not a common thing. It's kind of awesome to have. What you see here is, there was a great time where these were all 0, and then you have some spikes here. If you stretch it out over the week, you'll typically see some very high latency when we were probably testing, and then everything dropped down to triple digits. Over the last 2 days, you can see some interesting stats here and how it spread out over time. But what's interesting is you get all these stats basically for free. It's not an easy thing, and the bigger your system is, the more complicated it becomes. Prior to being at Google, I came through an acquisition back in 2010, and we were serving about 800,000 QPS on Amazon. So we were Google's biggest spender on Amazon, about $1 million a month. And with all those machines, collecting all the data, we needed a cluster of about 100 graphite machines just to measure that 800,000 per second. It was not an easy task to do, and if we had been using App Engine, we probably wouldn't have had to do that, and that's 80 machines we would have just gotten for free. In addition to this, you can see traffic utilization, the number of instances. You can see how App Engine scales you up and down over time, right? You can see in general, we typically have about 1 instance and sometimes peak up to 3. And there's little bits here we might be somewhere in the middle, which means for that time period, you had one turn on or off. And what this means is you can see exactly how you're scaling up and down. So Ray's going to talk a little bit now about the logs viewer.
Thank you. So as JJ said, one of the other problems you have is having too many data sources. Well, let's face it, you've got logs and metrics from every compute instance, and there can be easily hundreds of them. Not only that, you might also be using different resource types or even different cloud products. Aggregating and correlating all these data can be really hard. Let's look at how to do that on Google Cloud. What you're seeing here is the App Engine's logs viewer. You also saw in the previous session, that's where you look at all the operations and request log for App Engine. It aggregates all these logs from across all of your instances together, so you can view them together in near real time. Not only that, you can also do search and filter in these logs to narrow down to the specific event you're looking for, regardless of where it is generated. So let's switch to demo here. This is an app that I play with in my spare time. And as you can see here, you can filter by different modules, versions, different log levels, time frame, and you can search by specific attributes such as protocol or status, or you can search by regular expression. So let's say I care about all the error events in my app because they're probably stuff I need to fix. So let me look under the error events, and I see a few of them. And what I'm going to do is to expand them to see if I can get more clue on how to fix them. You can see that the entire cost stack is captured here in the logs viewer for you. And not only that, notice there are a couple of pretty special lines. So next to the methods that I actually wrote myself, you can see a file name and a line number. And not only that, it's blue and it's underscored, so it's probably clickable. Where do you think it takes us to? Well, so we have landed on the exact line of code that was responsible for producing the exception that you saw in the logs. So now you no longer need to go and open multiple logs files or code files, try to make sense switching back and forth between them. We have just made log to source linking simpler for you. So Google Cloud also integrates with third-party monitoring solutions to make it easy for you to monitor all aspects of application's health. And next, I'm going to welcome on stage the engineers from Datadog and Workiva to share their stories.
Hey guys, I'm Amit from Datadog. I'm just going to talk about what we do. So what we do is SaaS-based monitoring, and we'll monitor your cloud applications. There are a lot of themes around dynamically scaling applications, lots of components in applications, and all of this needs monitoring. And that monitoring is, you can set it up yourself, like JJ was talking about with Graphite or whatever else. It takes a lot of time and effort, and we make that super, super simple for you. So all the way from languages to data stores to web tier to infrastructure, we'll monitor it all for you inside of Datadog. And I'm going to show you a demo as well on how we do it. So not only that, we'll also capture change events within your application. So for example, if you're using configuration management tools or deployment tools, we'll gather changes from there and bring them in context with your performance metrics so you can see right after deployment if performance of your application changes, you can see it right there. And then we'll take all that data and let you build graphs and let you also use your favorite chat tools to chat with your teams, to collaborate over these metrics and performance and talk about them. So here you see a screenshot of people chatting about stuff over I think that's Slack. And now I'll jump into the demo. And I wasn't brave enough to try live demo, so I've set it up with a video. So here you can just go to datadog.com, sign up with your Google authentication, select that you're a Google App Engine user, fill out a very simple survey form optionally, and then go to next. And it'll bring you up to a panel where it'll ask you to configure your application for Datadog monitoring. Now here you'll see it's very straightforward. First thing you do is you clone our Datadog Git module. Next, you add a handler for Datadog inside of your application in the YAML file. Next, you set up an API key so we know where to get the data from. And then you set up the Datadog endpoint URL, which matches the handler, basically. So our crawlers will go out and start gathering metrics from Datadog and bring them back into our interface. And that's it. You're done. We'll now start gathering all of the same metrics that JJ was showing earlier and bring them back into Datadog. You can also configure all these other things. And I'm not going to go into any of them, but you can configure all these other components that you may be using inside of your application to monitor all of those as well. Here I'm going to show you how to create a dashboard. So this is just a basic time series dashboard. So we're setting it up. And here I create a time series. When I drop down the list, you'll see all of the GAE metrics in there. You'll see all the metrics from all the other sources as well. So if you're using Google Compute Engine and you're sending metrics from there, they'll also show up in here. So you select that. All the metadata associated with the metrics. So for example, here the project name, I can select the project name here as well. And I can add as many metrics as I want. So I'm getting the memcache hits and misses. And I'm graphing them. And that's it. The metrics are done. Here I'm adding another graph. And let's take request latency maybe. And then here, one of the things JJ was talking about earlier is versioning of your application. So one of the things Datadog does really well is it'll take metadata such as application versions, project names, et cetera, and it lets you graph performance of those things automatically rolled up by those tags. So for example, here I can say, take the latency and show it to me by version ID. So if you have two versions, I can see the latency of both versions graphed in real time simultaneously. And that's pretty much it. So you have it set up for Datadog, and okay, let's go back to the slides. So you can, just for the Google App Engine and Google Cloud Platform users, we have a free version available now. So you can set up to 10 projects plus 5 GCE instances for free. And if you need more, there's a free trial available. You can set up unlimited number of servers during this trial. And yeah, you can check us out. Next up is Ryan from Workiva, who uses us and GAE. And he's going to talk a little bit more.
Thank you. So I'm Ryan Bonham. I'm the production systems manager for Workiva. Workiva is a cloud-based data analytics company. We've got over 60% of the Fortune 500s using our Wdesk platform to make complex reporting easy. I'm here just to give you a quick walkthrough on how we're using Wdesk and, how we're using Datadog and App Engine together. So, the thing we really love about App Engine is it gives us the ability to focus on building our platform and making it better. And that's the great thing about Datadog as well, is it lets us focus on that and not on having that large scaling infrastructure of StatsD and Graphite and all the other things you would need to do this. So what are we currently monitoring? We've got 40 different app spots that we're monitoring with about 280 modules we're monitoring. Our infrastructure over the last week is what you're seeing here is the system instance count. We've scaled anywhere from a couple hundred instances to over 4,000 instances during that week and back down. And the nice thing is Datadog scales right alongside that to handle all those metrics coming up. So what's this really look like? What we've got here is we're taking data from multiple sources. We're using a custom Python application that we've written that's using the Cloud Monitoring API from Google to grab data from App Engine, data from Compute Engine instances. We're correlating data from BigQuery, our Splunk logs. We're even taking some events from our own internal deployment tool, pushing them all up via Datadog's REST API. And what you're seeing here is just an event stream of everything that's happened on a particular app spot. So what's this really look like? This is one of our, this is a part of one of our dashboards that we use. So what you're seeing here is latency, traffic, instance counts, status codes responses. You're also seeing URL response times that we're sending up outside of the Cloud Monitoring API. We're also, in the event stream there, you'll notice a deploy that's happened. We're able to correlate this. You're seeing these are two different modules, default and Big Sky F1. These are two modules we have on our application. So this is a really great way to correlate data from lots of data points across your platform and get a really quick view into it. The nice thing is, we take all these data, we push it up to Datadog, we set up alerts there that can then send notifications out to our operations team, our developers, our customer service teams as needed. And I hope you guys like that real quick view, and back to Ray.
Thank you, Ryan and Amit. So you want to get your monitoring data in real time so you can know exactly what's going on right now and what needs your attention. But at the same time, you also need to be able to look across a period of time and draw insights from history and analysis. And here are some examples. To do analysis on the App Engine logs that you just saw, you can export them into BigQuery. Now, BigQuery is Google Cloud's big data platform that can process fast queries over multi-terabytes of data. You're going to hear all about it in the next session, Optimize and Analyze. Money is important, right? So billing and cost are another very important aspect of application to monitor. Now, the developer console that you just saw would show you your current spending as well as monthly history. If you want to run any deeper analysis on your costing, then you can use the billing export and compute usage export to save the more granular data into your designated Google Cloud Storage bucket. The file you're seeing here is a JSON file that comes from the billing export. It shows you all important attributes of your cost structure, such as your project number, measurements, time frame, and resource type. With this file, you can now import it into a spreadsheet, or you can write a script to crunch the numbers. And you can use also additional cost optimization tools for application. So one example of such a tool we're going to see here is clouding. Clouding monitors and analyzes your Google Cloud deployments and gives you visibility into your usage, performance, and cost. It then translates these data into insights and actionable recommendations on how to optimize your cloud deployments, reduce cost, and maximize your cloud ROI. And the screenshot you're seeing here is the Clouding console combining the usage export with real monitoring data. It shows the cost of a Google Cloud application with daily resolution trending over weeks and months. You can also break down the cost by the different services, different instance types, or from business perspective by projects, campaigns, or business units. So far we have looked at a number of UI tools that are very useful to you, but I also know for many of you in your day-to-day job, command line is a preferred mode of working. So next, JJ is going to talk to us about the SDK and command line tools.
Right, so some of this stuff is going to seem, you've seen it before in previous demos. I just want to call attention to a few things and maybe explain a little bit about what we're going for with the CLI, the command line interface for Cloud Platform. So there's a few targets that we're really aiming for. One is installation and updating. Right now, we're focusing on a single line install. If you go to cloud.google.com/SDK, it's a copy and paste, it's a one-liner, and we're hoping to make that even easier with an apps repository and all that. That's on the docket. There's also this idea of a component manager. Say we update or fix some bugs. Say we add a new service. I think you saw this before in that G-Cloud Components update app. That was sort of the precursor I mentioned. This is the component manager in action. It's letting you say, I want to install a new piece with G-Cloud. Here's the new things that are available. You'll also notice that if you run a command using, say, G-Cloud Compute, and there's a new version available, you get an automatic prompt that says, do you want to update to the latest version? We fixed bugs X, Y, and Z. You can just hit Y and everything will sort of magically work. And this is one of those things that I think they're really important. It helps us make sure that the code running on your machine is actively the newest version. And then you also notice this environment setup. What I talked about before with that whole git push that just sort of magically works. This git gcloud init command is the thing that really makes that all happen. It sets up your local environment with the proper authentication and configuration options so that these things sort of just work out of the box. You shouldn't really have to worry about them. There's no generating an SSH key and all the entropy needed, then copying that somewhere, then doing all this work. It just sort of happens. In addition to all this, we want it to be relatively easy to learn and use. What that means is auto-completion has to work. I'm kind of lazy at the command line, and there's, for example, in Git, there's plenty of commands that I forget the order of things, or if I've typed, R, I want rebase to finish. With G-Cloud, you get the same sort of thing. If you hit tab when you're halfway done, you'll get either the options that match, or it'll autocomplete all the way through. Exactly like sort of a first-class citizen in the Linux world. Another thing is help text. I don't want to open up a web page every time I don't know what a command does, or how to use it, or all the details behind it, the performance implications, the examples. All these things I would want right away, and in the Linux world, I'd type man to get the man page. If you use gcloud --help, or in some cases just help alone, what happens is you end up seeing a man-style help text that explains all the details of how to use the command, just like I said, with performance implications, examples, and all the other details. And we're actively adding more and more to these to make sure that they're concise but still descriptive. Lastly, syntax. And this ties into this last piece as well, so I'll talk about that together. I don't know if anybody remembers in the old days when there was gcutil for compute engine, and then gcloud for other things. What we're really trying to do is consolidate these into one tool so that you don't have to install a bunch of different things to do this. And on the docket still, we have to add gcloud storage. That's coming up. But what we're trying to do here is make it so that everything's very consistent. For example, in this case, you see gcloud preview app. You'll notice that preview is going to be our way of trying out new things that are in beta, that are exposed to everyone, but it's not exactly a public thing. We haven't committed to it yet. We don't want you writing lots of scripts and then being upset if things change, so we put it under the preview flag. Otherwise, you have gcloud SQL, gcloud compute, all of the things that sort of just make sense. You run your gcloud, then pick a service, and then there's lots of commands that come with that service. So app for App Engine, SQL for Cloud SQL, and compute for Compute Engine. And there'll be more and more over time. And our goal here is to really have consistent and easy to understand syntax so that you don't run into problems where you run a command and it does the opposite of what you're expecting it to do, or you find out that the arguments are out of order because on the one command it looks like version A and over here it looks like version B. What we really want is so that all these things are really easy to understand and that you don't get confused and tripped up on stupid and frustrating things. So we're really trying to make that simple. So I just want to illustrate a couple of common tasks here, and you've seen these before in the previous examples. Frances's presentation actually covered a bunch of these, and I think Wes covered some of them as well. So this is compute instances list. I don't know if you can see that. I'm trying to light it up. What this does is it tells you which compute engine instances you have running. Right? All this means is that you're going to see the list of things, the list of machines, the instances that are up in your account. And I've blocked out the IPs, obviously, but it gives you all this data. Now, because it's a regular Linux command, you can pipe it in through less, or if you want to grep for something, you can pipe it through grep, right? These are all just basic Linux tools with standard output. And so that means that you can use cut if you wanted to just pull out all the external IPs of your machines, right? So you use your regular Linux tools. Here you have gcloud DNS managed zone list. Hoping you can guess what that is. A managed zone is a thing that contains domains, right? And so in here you're seeing a list of JSON output that basically has all the details of the domain that that you have registered. So there should be a bunch of them. And if you have a JSON tool that processes standard out, you can always just pipe this through things like jgrep or whatever else you want. And then you can filter through if you want to pull out some data, or pipe it through a Python script or whatever else you might want to do. And lastly, this is the example I mentioned before with the component manager. This idea is I want to be able to just update everything that's available. So you're on gcloud components update. And what will happen is you'll see all these things that may have been updated since your last run. Now, keep in mind, you'll still get the auto prompt whenever you run a command if there's something new, because we want you to have the latest version. But this is your way of saying, before I even start, I want to make sure everything's up to date. And so if you were running a script, for example, and you want to make sure you have the latest version, you could just put this at the beginning, and then everything will make sure that you have the newest version before you go. So that's all we have for today. We have a few minutes left for questions. As far as I know, anything is fair game. I have a lot of experience with all this cloud stuff, and Ray here is a product manager, so we have tons of things to answer if you have anything you're curious about. But thanks for watching.
And we also want to give you the links to the open source GitHub projects for the Abalana app that we promised.
So yeah, the first
we'll keep it up. So
yeah, we'll leave this
take
up
a photo,
questions.
write them down.
So yeah, the first one is the GCP. That's the server side, the Go code. And the second one is Abalana Android. That's the Android app Java code. And so you can look at both of those. If you just go to GitHub/Google Cloud Platform, you can browse all of our stuff. So there's plenty of things that are available there if you're curious about what we're working on in the open source world. But these are the two from today.
One of the biggest challenges with running multiple versions is data versioning, right? When the data model changes, what do you do? What are the best practices that you follow?
So I can't speak to the current version of how things are. Just to repeat the question in case anyone's curious, in this idea of separate versions, what happens if you have separate concepts of like the data model? Say you are adding a new field, and in the new version you have the new field, in the old version you don't, or if you have it the other way around, you're removing a field. How do you deal with this across inside Cloud Data Store? You're thinking of Data Store, yeah?
Yeah, I mean, typically both NoSQL, which is flexible schema, and Cloud SQL, which might have a schema.
So the best practices, I mean, are the standard ones where you're supposed to take the common denominator there and make sure that your code can operate in both environments. Data changes are not hugely recommended with separate versions inside App Engine, but you can still do it. And we're actually working on some really cool stuff for Data Store, and it should be out somewhere in Q2, Q3, where the idea is we'll have an overlay on top of things, and you'll be able to operate on that and test it. And that way you'll be able to sort of change data without actually changing your production data. And we're still working on timelines. We don't know for sure, but we're trying to address that problem.
Right.
And another common practice we've seen here is instead of using the different versions, then you actually use different projects. For major releases where your data actually changes enough, then you don't want your, say, staging code to actually damage your production data. Is to set up different projects, and that's where you get very separate partitions between the data of the two versions.
Yeah, so separate applications can fix the problem as well.
But one of the other challenges when we come from the SQL world to the NoSQL world is writing too many migration scripts, right? For example, if you have a SQL script, you will just do an update if you rename a field, for example. But if you have to do it on App Engine Cloud Data Store, you have to do a whole lot of batch up. So how do you deal with those kind of situations in large databases?
I think this is a problem across a lot of NoSQL options, not just data store, right? Instead of having a concept of a schema and a column, you have a dictionary style of data where to actually do this, look at MongoDB, for example. To do this, you actually have to go through and update each item. So there's no easy way to do this except for kind of deal with the bad column name. It's not no great answer for that, but I don't know any better option. So.
Do you deal with it in code, or what do you recommend?
For migrating data along the way, I think the App Engine best practice is to have it iterate through each item if you really need to clean up existing old data. And it can be both CPU intensive and therefore cost intensive, so it's not hugely recommended. But if you really need your data to look that way, that's sort of what you're going to have to do.
All right, thank you.
Sure.
You talked for a second about splitting versions and slowly migrating. Do we have tools available for checking, say, error rates or latency on requested given URLs so that we can more easily identify when we need to go, oh shit, and roll back versus when we're happy with the deployment?
So I think that's where, for example, integrating with Datadog, you can track metrics from different versions and then set alerts for them. So that will enable you to deploy something to a staging version and then start switching traffic. And with alerts and monitoring on your new version, if you start seeing latency bump up or error rates bump up, you can get an alert and you will know to stop it from further migrating, right? Roll back the percentage traffic so you can actually fix the new version before you roll out deployments again. And
in the logs where you saw, there was that drop down where you can choose a version. And so if you happen to be watching it at a particular time, you can pick which version and see all the logs that are coming through, filter by errors on version X, and then you can see what's going on. But hooking into Datadog is more of the push concept where you can set alerts on that data. Oh, and cloud monitoring. Yes, that also. Sorry? Yeah, it's a product that we have. We're trying to talk about Datadog, Jeremy. Yeah, so cloud monitoring is another tool that does similar things where you can alert on these different metrics. And it's in beta now, Jeremy? Early access. So you don't have access to it today unless you're on the whitelist. Soon it'll be in beta, which means it'll be open to everybody.
And if you want to be added to early access, Jeremy is the guy in charge of it. Go talk to him.
Purple shirt in the back. He's leaving now. Sorry, go ahead.
Hello. Yeah, my question is about the cloud debugger you talked in the keynotes. When you talked in the logs part, that you can go to the line with the problem, that's fine. But what about debugging in the production environment?
Yeah, so in the other track upstairs, the next hour, the runtime insights talk is going to talk in more details about debugger and also show you a demo of the debugger. But it's kind of both, the log to source link and debugger kind of follow the, if you deploy your code through push to deploy, and so we can keep the metadata and understand what's the version running in production and which version of code it relates to. Then we can, do all this linking between a log and source code, as well as set debugging points for you.
And if you want to ask more, Melody is right here, and she knows everything about Cloud Debugger.
Great.
Hey, you guys mentioned analyzing logs with BigQuery. Is there a way to automatically get your App Engine logs with the BigQuery?
So in the next session, you're going to look at more details there, but also the functionality to automatically export log into BigQuery is on its way. Again, Jeremy is probably the person who can comment on exactly when you're going to get it. This quarter. Okay. It's going to come as a Christmas present.
Okay. Thanks a lot, everybody. Really appreciate it.
Thank you.